Okay, so I'm going to do problem 4. The problem statement is a straight wire 15 meters long, the rest of the circuit is not shown here, oriented along the y-axis lies below a compass as shown, like that. The wire is much longer than is shown here and the diagram is not to scale. The compass is centered on the origin and is 4 millimeters above the wire. When a conventional current of I amperes flow through the wire, the compass deflects 8 degrees to the west. So, problem A says on the diagram to draw the direction of the conventional current in the wire, and then to explain it. So, if the compass is deflecting to the west, that means there has to be a B field going this way, a magnetic field going that way. Which means in order for it to deflect this way, the current has to be going down. Using the right-hand rule, the B field goes counterclockwise, so the compass deflects to the west. So part B says to determine the magnitude of the current flowing through the wire and to show all the work. And it gives you the Earth's magnetic field as 2 e to the 5 teslas. So B of the wire is equal to B Earth times tan of theta. So B of the wire is equal to 2 e to the negative 5 times tan to the 8 degrees. And when you put this in the calculator, B of the wire equals 2.81 e to the negative 6 teslas. Now we can use the B field of the wire to find the current. So if we use the formula, B equals mu naught over 4 pi times 2 times the conventional current over R. Then we can solve for I. So this gives us I equals B, I equals B times R divided by 2, 1 e to the minus 7, because that's what the mu over 4 pi equals. When we plug in the numbers, this becomes our magnetic field that we found at the top. So it's 2.81 e to the negative 6 times our radius, which is 0.004 meters. This is divided by 2 e to the negative 7. And when you put that in the calculator, I equals 0.0562 amps. And that is the answer for part B. Part C gives us these 4 drawings with different rings located at the compass. And the statement says, with the current still running in the straight wire, a current carrying loop is placed near the compass, and the compass now deflects 16 degrees to the west. And it asks you to find which of the diagrams indicates where the loop was placed. And so you have to choose one. And it needs to be consistent with part A. So the way I did this was I used the right-hand rule to find which ring gave the B field that pointed to the west. So on this first one, the ring is going clockwise, which means the B field is going down. So that's wrong. The second one, it's on the other side of the compass, and it's still going clockwise, which gives the magnetic field pointing down. The fourth one has the ring flipped, and it's going counterclockwise on this side of the compass, which means the B field is going this way to the right, so that's wrong. So this one, using the right hand rule, it's on the right side of the compass and it's going clockwise, which gives a magnetic field pointing to the left, which is the right one. And that is the end of the problem. Bye.